Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 says to match each type of titration to its pH at the equivalence point for solutions at 25 degrees Celsius. Okay, so I'll just write all the different types of titrations. You could have a strong acid and a strong base titration. And its pH at the equivalence point is neutral, that's around 7. And you could also have titration of a weak acid by a strong base. And the pH at the equivalence point of this type of titration would be greater than 7. So this is because when we have a strong base, because it kind of overrides more of the pH compared to the weak acid, and bases have a pH greater than 7, then the same goes for our equivalence point. It will also be greater than 7. And then lastly, we could then have a strong acid and weak base titration. And the equivalence point for these types of titrations will be less than 7. Again, because acids have a pH that is less than 7. And since we have a strong acid compared to a weak base, at the equivalence point, the pH will be less than 7. Okay, so let's see what the junior tutor said. Titrations that are from strong bases and strong acids do not hydrolyze. pH of these salt solutions will remain 7, because the ions comprising the salts will completely ionize in water. Halides and alkali metals dissociate, do not affect or alter the concentration of hydrogen ions, as the cation does not alter H+, and the anion does not attract H+ from the water. In general, salts containing halides, except fluorine, and an alkaline metal, except beryllium, will dissolve completely. Titration from strong bases and weak acids give a pH greater than 7. The anion of the salt is derived from a weak acid and will accept the proton from the water in the reaction, leaving a hydroxide ion. And the presence of hydroxide ions makes the solution basic. On the other hand, the cation from a strong base will dissociate into an ion and will not affect the concentration of H+ ions. Lastly, contrary to the previous one, the cations from the weak base will attract hydroxide ions, leaving the H+ ions from water in the solution. The presence of H+ ions indicates that this solution is acidic. Yep, so this solution is correct.